This video is for Year 11 Methods. It comes out of Chapter 6. It's 6.8.19. In general terms, find the points of intersections of the two functions. f of x is a parabola, g of x is a straight line. We know that when a straight line and a parabola are drawn, there could be no intersection point, one intersection point, or two intersection points. To find the points of intersection in A, we need to set the two functions equal to each other and solve for x. I'm going to put everything on the left-hand side. 3x squared plus 4x minus ax plus 5 minus 2 equals 0. 3x squared plus 4 minus ax plus 3 equals 0. And I'll use the quadratic formula. That will tell me that x will equal minus b, so minus 4 minus a, plus or minus the square root of b squared, so 4 minus a all squared, minus 4 times a, which is 3, times b, which is 3, c, which is 3, all over 2a, which is 6. And that gives me minus 4 minus a plus or minus the square root of 16 minus 8a plus a squared minus 36 all over 6. Therefore x equals minus x minus 4 minus a plus or minus the square root of a squared minus 8a minus 20 all over 6. Now, I think the question's asking for the x values of the points of intersection, because to actually find the y values, we've got to sub this into this expression. So I'm just going to leave that in terms of x. Part B then asks, find the gradient of each of the two functions at the point of intersection. Okay, well, the gradient of the two functions at the point of intersection for g of x, I'll find the gradient by taking the derivative. And g dash of x is the derivative, and that equals a. So the gradient of g of x is a. Doesn't matter where it is, at the point of intersection or any other points on g, then the gradient will equal a. And f dash of x will equal the derivative of this. So 2 times 3 gives 6x plus 4. And that varies. No matter where you are, the gradient will be different. So I'm going to sub this value of x into it to find out the gradient when x equals 4. So the gradient when x equals this is m equals 6 times minus 4 minus a plus or minus the square root of a squared minus 8a minus 20 all on top of 6 plus 4. That's going to equal, notice the 6's cancel to leave factors of 1. Minus 4 plus a plus or minus the square root of a squared minus 8a minus 20 plus 4, which equals a plus or minus the square root of a squared minus 8a minus 20. That's the gradient of f. A is the gradient of g. They're the two answers for part B. In part C, if g of x is the tangent to f of x, if g of x is a tangent, therefore g and f have the same gradient where they touch. I know that the gradient of g is a. I know the gradient of f is 6x plus 4. I know that the gradient equals, a plus or minus the square root of a squared minus 8a minus 20. So I need to make a equal to a plus or minus the square root of a squared minus 8a minus 20. Rearrange, I get plus or minus the square root of a squared minus 8a minus 20 equals 0. Square both sides, a squared minus 8a minus 20 equals 0. Crisscross a 10 to negative on the 10. Therefore a minus 10 and a plus 2 equals 0. Therefore a equals 10 or negative 2 will be the values of a that make it equal, that make it a tangent. Now, if I was to have a little look, if I consider one is a parabola that goes through at 5, and the other is a straight line that goes through at 2. When a equals negative 2, so let's be down here 2. When a equals negative 2, then the gradient of this one is the gradient of negative 2, and that might give you one of the tangents. And when a equals 10, you also get another tangent.